So in this lecture we are going to see the priority scheduling. That is, priority scheduling is a kind of scheduling algorithm which come under the category of primitive and non-primitive, but now we are going to see the primitive priority scheduling algorithm. So in this primitive priority scheduling algorithm, let me start with seeing the process and its priority, burst time and arrival time. So here there are 5 processes are there, and each process is holding a priority, that is 1, 2, 1, 3, 2, and each process is having the burst time, and each process are having that own arrival time. So in process P1 and P2, its arrival time is 0, and process P3 is 6, process P4 is 11, and process P5 is 12. Now at the time 0, process P1 and P2 arrived, but P1 is holding the highest priority than P2. So the execution begins with process P1, which has the burst time 4. So the process started its execution with comparing the priority by P1 and P2. So P1 is holding highest priority, so P1 is executing first. So at timer 1, there is no other process is coming with highest priority, and time 2 also there is no process coming with any priority, and time 3 also no process arrives, and time 4 the process P1 completes its execution and it's leaving the queue. Obviously there is only one process in the queue, that is P2. Next, at the time 6 only the process P3 is coming. So there is no other process, so the P2 is entering into the queue for executing. So the next, at the time 5, no new process are coming, so P2 is continuing, and at the time 6 P3 is coming with priority 1. Here note it down, the priority of P2 is 2 and priority of P3 is 1. P2 starts its execution at the time 4, P3 coming at time 6. So the burst time of P2 is 3, but it executes only its 2 burst time. So the remaining 1 burst time is available with P2, and P3 is coming and it is holding the highest priority. So P2 will be waiting inside the queue with the remaining 1 burst time. So now P3 is holding the highest priority. So P3 starts its executing, and P2 is waiting inside the queue, and P3 starts its execution. At time 7, no new processor arrived, and time 8, no new processor arrived, P2 still in the queue, and time 9, no new processor arrived, and time 10 is also no new processor arrived, and time 11, P4 arrived with priority, P4 arrived with priority 3 and burst time 4. So here P3, when compared with P3 and P4, P3 is holding the highest priority, which is P3 is currently running. So compare the currently running process with arrived process, the priority is very low when compared to the P3. So P3 is continuing its execution. So now P2 is in queue with 1 burst time, and P4 is in queue with 2 burst time. So P3 continues its execution. At time 12, one more processor coming, that is P5, but still P3 is holding the highest priority, so P3 continues its execution. So at the time 12, P3, no new processor arrived, so P3 is continuing its execution. Currently P2 is in queue, P4 is in queue, and P5 is in queue. So at the time 13, P3 completes its execution, and we have 3 processes in queue, that is P2, P4 and P5. So here P2 and P5 holding the same priority, that is 2, but P4 is having the priority 3, but P2 and P5 is having the equal priority as 2. So now we have to compare the burst time of this specific 2 process, that P2 and P5. So now the arrival time is P2 is before P5. So So P2 will start executing. At the time 14, 13, P1, P2 enter into the queue and P2 starts its execution. Then at time 15, P2 is having only one burst time, so P2 completes its execution as time 14, and at the time 15, P5 is entering into the queue because when compared to P5 and P4, P5 is having the highest priority when compared to P4. So P5 is getting inside the queue. So after the completion of this P5, at the time 16, there are only one process inside the queue, that is P4, and P4 starts the execution. Then at the time 20, P4 completes its execution. There is no other process residing inside the queue. So next we have to calculate the average turnaround time and waiting time. Here, calculating the turnaround time, we have some formula, that is turnaround time is equals to completion time minus arrival time. So the turnaround time is equals to completion time. So the P1 completion time is 4, P2 completion time is 14. It is the P2 completion time is 14, and P3's completion time is 13, and P4 completion time is 20, and P5 completion time is 60. So the process is coming inside the queue. According to the priority, the process is working. So it having the different completion time. So we have to take this completion time into account, and we have to subtract this completion time with arrival time. The process P1 and P2 come at the time 0. So 4 minus 0 is 4, and 14 minus 0 is 14. And P3 arrival time is 6, and P4 arrival time is 11, and P5 arrival time is 12. So by that way we have to compute the turnaround time. So we have to calculate the average turnaround time, that is we have to sum up all these values and divide it by 5. And next we have to calculate the waiting time of this process. So the waiting time is nothing but it is a turnaround time minus burst time. Here we computed the turnaround time very clearly, so we have to take that value into account, and minus we have to subtract the execution time of each and every process. So the execution time is otherwise called as in burst time. So the execution time of P1 is 4. So the turnaround time of P1 is 4. So 4 minus 4 is 0. Then the execution time of the P2 is 3. So 14 minus 3 is 11. The execution or burst time of P3 is 7, the burst time of P4 is 4, and burst time of P5 is 2. So likewise we have to compute the waiting time. So we have to calculate the average waiting time, that is 3.6. So by this way we have to calculate the average turnaround time and waiting time. Let I conclude this lecture as, so we just seen what is an preemptive priority scheduling. Preemptive means if the process is running, the other process is arriving at the queue with the highest priority, means the currently running process will stop and it will check the priority. The priority of currently running process is high, it continue to execution. If the priority is low when compared to the arrived process, the currently running process will stop and it will give the CPU scheduler to the arrived process for running. So this is all about this scheduling algorithm.